Okay, we have written an interesting integral from the Chennai Math Institute 2025, number 6. We have the integral of 1 plus 2x cubed over 1 plus x squared minus 2x cubed plus x to the 6 dx. Okay, one thing I noticed about the CMI integration B is a lot of the problems are harder than they look. I think the trouble is they usually choose a lot of routine looking problems, but maybe with difficult factoring or a complicated u substitution. In this case, I think it's a little hard to do the factoring just because I don't think there's a good way to factor this whole thing. But if we separate out just some of the terms, if we kind of ignore the x squared and factor out everything else, if we just look at this, if we just look at x to the 6 minus 2x cubed plus 1, this we can deal with. What I could do is x to the 6th, I could write that as x cubed squared, and then we can treat it like a quadratic. And the way this is going to factor is we could just do this as x cubed minus 1 all squared. So let's just take this and we'll plug it back into our integral in the denominator, and let's see what we have. And then here, it's still not clear how it's going to work. Our denominator is still kind of a mess. What we can do to clean that up is let's multiply in. If I multiply in here, if I multiply in by 1 over x squared here, that's going to become a 1. And so I don't change it, we can do the same thing in the numerator. So we're just multiplying by 1. Now when we do it, first we'll multiply into the numerator, but actually for the numerator, I'm going to kind of just leave it. We'll just leave it like this because I think it's going to work nicer this way. But then in the denominator, I'm going to multiply this in. So again, 1 over x times this is going to give me a 1 here. And then here we're going to, because both things are squared, I can write this as x cubed minus 1 over x all squared. And the reason for doing this is when we have something like 1 plus something squared, it looks like we can use the arctan formula, but first we need to do a u substitution to clean it up. So I want to try a u sub on this right here. So we're saying u is going to be just x cubed minus 1 over x. And actually, I think let's simplify this. If I just divide in the x, we get x squared minus 1 over x. Go ahead and take a derivative. So du is going to be 2x. This here is going to become positive 1 over x squared. So actually, I probably should have just multiplied this together earlier to make this work. So let me show what that is. So if we multiply in the 1 over x squared, I'll change the order. So 1 over x squared times 2x cubed is going to be 2x. Multiply it into the 1, we get plus 1 over x squared. So this is going to work perfectly because everything we have here, this is exactly our du. So we'll go ahead and substitute. What this is going to boil down to is just going to be du for the whole numerator and 1 plus u squared. So we'll go ahead and integrate. This is just going to be arctan, so we get arctan of u, but let's just back substitute it. So what we have here is going to be arctan x cubed minus 1 over x, add a plus c, and that's it. Now, a few comments on this before we finish up. It's kind of interesting how fast it goes after you get the first step, which is kind of complicated. So it's really quick, but not necessarily easy. The other thing that's interesting is there is quite a few different variations because when I factored it, I changed the order. So instead of having x cubed minus 1, you could easily have 1 minus x cubed. The other thing, for this step right here, I divided in 1 over x squared. There's definitely a choice here. We could do the same kind of thing, dividing in 1 over this thing, 1 over x cubed minus 1 all squared. That way this term becomes a 1. On this term over here, you'd end up with the reciprocal of this, right? I think you'd end up with x over x cubed minus 1. You do the same kind of substitution and you get arctan again, but then you get the reciprocal. The reason the answers are the same, we have this formula. If you've got arctan of x plus arctan of 1 over x, this is just pi over 2 when x is greater than 0. And it's going to be minus pi over 2 when x is less than 0. So either way, what happens is the solution you'll get doing the other substitution, it's just going to be off by a constant because the inputs here are reciprocals. So if you rearrange this, like if you solve for this, it's only going to differ from the reciprocal by a constant pi over 2 or minus pi over 2. Okay, so there you have it. That's it for today. Thanks everyone for watching. Have a good day.